Okay, good morning, everyone. I'd like to start the event now. And good evening to those who are in the United States of America. Welcome to the 2022 IUPAC Global Women's Breakfast with the theme, Empowering Diversity in Science. I am Dr. Gladys Completo from the Institute of Chemistry, UP Los Baños. And with me are my co-hosts, Dr. Cheryl Ariola and Dr. Aimee Del Mundo. So this event is hosted by the Philippine American Academy of Science and Engineering in partnership with the UPLB Institute of Chemistry and Integrated Chemists of the Philippines and Advancing Chemistry for Tomorrow. So PAASE is a nonprofit organization composed of scientists and engineers of Philippine descent who have distinguished themselves in scholarly and research-related activities. Our mission is to contribute to national progress through the improvement of STEM ecosystem in the Philippines. Last year, we started hosting this event with the aim of inspiring our younger generation to pursue science. And today, we celebrate the 2022 IUPAC Global Women's Breakfast, focusing on the achievements and contributions of women across the world. Women as citizens, mothers, daughters, leaders, and scientists. Women who, just like men, are trying to make a difference in this world. So I would like to start this event by sharing a video prepared by the Iupac organizers so that you'll better understand the purpose of this event. Let me just share the video.
Good morning, everyone. Welcome to the 2022 Iupac Global Women's Breakfast. Mary, I'm thrilled to partner with you again to launch this amazing event.
Hello, Laura. We have the great honor together to greet everyone and to welcome them to this year's celebration of the achievements of women in science. I can picture scientists all around the world leaping out of bed this morning to meet with their friends and colleagues.
The wonderful thing about the breakfast, Mary, is the warm feeling of belonging and shared purpose with the more than 300 groups around the world.
You and I both have a great appreciation for the critical importance of building professional networks.
You know, amazingly, both of our journeys started with a fascination with chemistry and water. Inspired by my first environmental chemistry professor, I got to travel on research ships on the world's largest lakes, and I met scientists from different countries who became mentors and collaborators.
And in my case, I would never have imagined as an undergraduate studying chemistry in the UK that I would move to do postdoctoral research underwater on the Great Barrier Reef. But it was while attending regional meetings in Asia that I first became inquisitive about how other communities do their science and how young people develop into well-rounded scientists.
For me, it was an IUPAC conference where I came to understand the enormous value of networking at an international forum.
Absolutely. We met at an IUPAC meeting in Puerto Rico. Now watch some of the wonderfully creative groups sharing what this year's breakfast means to them.
Unity in diversity.
Wow, those were amazing. I'm really excited to announce today that the next breakfast will be held on the 14th of February, 2023, and registration will open later this year, so keep an eye on the website.
That's Valentine's Day. And next year, the breakfast will also be part of the celebration for the International Year of Basic Sciences for Sustainable Development. So we encourage you to reach out to organisations in other maths and science disciplines to organise an event or to join your event.
And finally, we ask you to join the global conversation about the breakfast using our short Mentimeter poll. Just scan the QR code with your mobile device to participate, and you can see the results in real time as they come in on the GWB website.
Thank you to all the event organisers, to our GWB task group members for their work this year, and also thank you to our sponsors.
And sending out a special thanks to Dr. Lynn Sobey, Executive Director of Iupac, for her leadership and support.
Have fun, everyone, and we will see you again next year.
There you go. Please don't forget, next year, February 14, we will have another Global Women's Breakfast, as is sponsored by PAASE. So without further ado, I would like to introduce now Dr. Lilibeth Koo, who will give the opening remarks. Sorry. Okay, let me introduce her first. Dr. Lilibeth Koo is a full professor at the Institute of Chemistry, University of the Philippines, Diliman. She previously held the position of lab manager of the Institute's Analytical Services Laboratory and as deputy director for administration. Dr. Koo earned her BS and MS chemistry degrees from the University of the Philippines, Diliman, and her PhD in analytical chemistry from La Trobe University in Melbourne, Australia. She has worked as a technical expert in various government panels, such as the Philippine National Police Working Group on Controlled Chemicals, Philippine Congress, Codex Methods of Chemical Analysis and Sampling, and various programs of the Department of Science and Technology. Dr. Koo is currently the National Treasurer of the Integrated Chemists of the Philippines. She actively takes part in the ICP's long years of untiring service to the improvement of the chemistry profession and its stakeholders. Let us all welcome Dr. Lilibeth Koo.
Thank you very much, Gladys. So allow me first to warmly thank the organizers of this momentous event, the Iupac Global Women's Breakfast 2022, Empowering Diversity in Science, headed by the Chemistry and Biochemistry Research Expertise Cluster of the Philippine American Academy of Science and Engineering, PAASE, and co-sponsored by the UPLB Institute of Chemistry, Advancing Chemistry for Tomorrow, ACT, and the Integrated Chemists of the Philippines, ICP, for giving me the privilege of welcoming and addressing you all. For me, it is an honor and a pleasure. I would also like to thank them for having brought us women in science and men guests together again in one venue in this wonderful city of Zoom, in order to get to know the many women in science who are the shining stars of our universe. Examples of shining stars who are here with us today, we have our speakers, Dr. Senia Tigner, Dr. Maria Margaret Peña, Dr. Christina Binac, Dr. Jalik Jane Fojas, our hosts and moderators, our beautiful hosts and moderators, Dr. Gladys Completo, Dr. Cheryl Ariola, and Dr. Aimee Del Mundo. PAASE Board Directors, PAASE President Mario Santo Domingo, and Dean Dr. Maribel Sese. So, women in science, each one of us, one way or the other, will have her own vocation within and beyond our work. We are anyway naturally nurturing, ever ready to go that extra mile in achieving our personal and professional goals or the mission vision of our organizations, be it PAASE, ACT, or ICP, all with the end goal of contributing through science to Philippines' national progress and also to the enrichment of the ever-evolving landscape of knowledge. I am a scientist myself, a chemist in the academia, dutifully imparting knowledge and skills and mentoring in the analytical field of chemistry to UP Diliman's undergraduate and graduate students and young researchers. But fate has it also for me to be voted into the ICP National Chapter. ICP, as you know, is the accredited professional organization of registered chemists and registered chemical technicians. So as a member of the board of directors, my added or attached work extends beyond the classrooms and into the real world laboratories in the academe, government, and the industries as one of the guardians of practicing chemists and chemical technicians. ICP prouds itself as the primary partner of PRC or Philippine Regulatory Commission in enhancing the professional upgrading of Filipino chemists and chemical technicians through its continuing professional development and career progression specialization programs, and in the promotion of high standards of Philippine chemical laboratories and compliance to local and international standards, among others. So, this morning will be dedicated to cover a good spectrum of brilliant and interesting stories of 4 eminent women scientists in the forefront of their chosen fields of specializations. I'm sure you are all eagerly anticipating to hear their narratives and breakthrough ideas and be inspired by them. They who have pursued their individual dreams and successfully making them happen. Roads taken that led them to where they are now could be short and straight, could be also long but effortless, could also be with narrow corners and sharp turns. Nonetheless, experiences gained will be worth sharing, I know, and will definitely open doors of great opportunities, especially to our aspiring young scientists. These experiences are gold mines of valuable lessons, full of beneficial and rewarding pointers and tips that would serve as models for our rising scientist stars in their pursuit of excellence in their chosen fields. Now, I am sure that each one of you will identify subjects of her interest and will benefit from many fruitful and enriching discussions hereon. The program is warming up, so on behalf of the organizer, PAASE, and partners, UPLB IC, ACT, and ICP, it is my pleasure indeed to welcome you all to an inspiring and productive morning. Mabuhay!
Thank you, Dr. Lilibeth Koo, for that a very warm welcome message. So far we have 259 attendees. We have from the US, from Florida, from Texas, Maryland, and then we have from Bicol, Coron, Palawan, Batangas. Anyway, thank you for attending. So we would like to start now with the presentations of our guest speakers. So I would like to call on Dr. Aimee Del Mundo to introduce our first speaker. Aimee?
Thank you, Ma'am Gladys, for that. So good morning or good evening to everyone. Thank you, Ma'am Lilibeth, for that welcome, warm remarks. And as mentioned, I will be introducing our first speaker. But before that, I would like to mention that Sharon and I will be moderating this discussion. So for our participants, if you have some questions, feel free to use the chat or raise your hand and we will try to monitor them. So we definitely have a great rock stars of science. And there, great line of speakers, and I hope you're all excited as I am. So to kick things off, let me introduce Dr. Senia Tigner. So when I read Mom Senia's bio note, I suddenly feel like she's the epitome of somebody who can say, been there, done that. So just to recap some highlights of her career, to correct that, it's multidisciplinary and international career. So her bachelor's is in physics, master's in physiology and epidemiology, both in UP. Then she got her PhD in natural science at the University of Würzburg in Germany. So in between those, she also had numerous job descriptions. One of them is that she taught medical physiology for nearly 30 years at the UP College of Medicine, even becoming the professor and chair of the Department of Physiology. She was also at some point a bench scientist, which I can say most of us here are, in various international world-class, world-renowned laboratories, including that of the famous CERN laboratory, as well as the National Cardiovascular Institute in Osaka, Japan. Then she became a program officer at the National Heart, Lung, and Blood Institute of National Institutes of Health here in the United States in Maryland. And currently she is the Associate Director for Careers at the Office of Research on Women's Health under, again, NIH, where her current efforts are towards the advancement of women and promoting diversity and inclusion in academia. And today, she will aptly tell us about the different levels of gender, racial, and ethnic disparity, which I would like to say currently plagues the US STEM workforce. So, Mom Senia, the floor is yours. Take it away.
Thank you very much for that very kind introduction, and thank you also for inviting me to participate in this panel today. For those who attended the PAASA meeting in October, I'm sorry some of the slides will be a bit redundant, so apologies for the redundancy. So Dr. Completo, I'm hoping you will advance the slides for me at this point. Yeah.
I don't know why it's not going. Okay. Now I know. Hold on. What's going on? Why am I not able to share it? Hold on. Sorry about that. Let me just, okay. Can you see it now? No. Yes. Is this okay now?
Yeah, just put it on. Yeah, okay. Thank you. Thank you very much, Gladys. So the title of my talk today is the Gender, Racial, and Ethnic Disparities in the US STEM Workforce. I'm sorry that it is concentrated on the US because that happens to be where I am at the moment and where we see that a lot of disparities are actually taking place. Next slide, please, Gladys. So I would just like to say at the outset that the opinions expressed are mine. The data is not mine, but are all from the US government actually, but the opinions expressed are those of myself and not of my office, the NIH, or the federal government. Next one, please. So I will be discussing today the labor force in general in the US by race, ethnicity, and sex, particularly that in the STEM fields. Next one, please, Gladys. So the points of discussion will be the labor force disaggregated by sex, race, and ethnicity, the STEM workforce and participation by sex, race, and ethnicity, a little bit about the representation of women in the health sciences workforce, and finally, this is a something new that I've added and which we have only revealed in the last month, the sex, race, and ethnic representation of the National Institutes of Health workforce, as well as the community that we fund, which is like the entire the United States and their laboratories. Next one, please. So this slide shows the different racial and ethnic groups in the United States and their participation rates in the workforce. So if you see here, among the race and ethnicity groups, Native Hawaiians, other Pacific Islanders, and 2 or more races, as well as Hispanics, constitute the highest participation rates in the workforce of the United States. That means to say that if there are 100 Native Hawaiians, then say 70 of them are actually working. Next slide, please. Now, across the races and ethnicities in the US, by the way, races are white, Black, Asian. Ethnicity refers to Hispanic or non-Hispanic, whatever race you may be, whether you're a Black Hispanic, Asian Hispanic, or whatever, you're considered Hispanic by ethnicity. But for race, you have white, Black, and Asians. So across all races and ethnicities, if you look at the percentage or the proportion of bachelor's degree or higher than bachelor's degree holders, the greatest number is among the Asians, with the Hispanics, on the other hand, being the lowest or the smallest proportion of bachelor's and higher degree holders. Next one, please. Yeah, and then among the employed men by profession, so these are different professions where they can be involved with. If you look at the Asians, 57% of the Asians work in management, professional, and related occupations, while among the Blacks, 20% or more among the Blacks and Hispanic work in what we call service occupations, so the yellow bars. And employed Black and Hispanic men were also more likely than white and Asian men to work in production, transportation, and material moving fields. Next one, please. When we look now at the science and engineering degree recipients across the United States, and this consists of the US population aged 20 to 34. The whites, who are represented here as the black bar, constitute 69% of doctoral degree recipients and 61.2% of master's degree recipients. So the whites predominate. But the whites in the United States comprise 54.4% of the population, but they get 69% of doctoral degrees and 61% of master's degrees. So clearly they are overrepresented in science. Now, the Asian population is only 6.6% of the US population, but they obtain 10.6% of the doctoral degrees in 2019 and 11% of the master's degrees. That is why in the United States, you often say Asians and whites are overrepresented in science, because relative to their proportion in the entire US population, they are overrepresented in that sense. On the other hand, Hispanics, who comprise 21.3% of this age group, only obtain 8.4% of doctoral degrees and 12.2% of master's degrees in S&E, while Blacks, which comprise 14.2% of this population, only earn 8.1% of doctorates and 11.3% of masters. So they are considered underrepresented minorities. Next one, please. So this is the breakdown if you prefer it in numbers. So like whites, they're 54% of the population, but 70% of doctoral degree recipients. Next one, please. Now, the civilian labor force by sex, women's participation has been constantly rising since the 1950s. So the gender gap has actually decreased across time. Next one, please. This slide shows that Asian women, here in black, and Asian men outnumbered all other races, including whites, in possessing advanced degrees. The black one refers to advanced degrees in science. Next one, please. So the US STEM workforce has now been recategorized. So originally we say that the STEM workforce consists of people who have at least a bachelor's degree in science. But recently they have reinvented the term to include also other workers who use science and engineering skills in their jobs, whether or not they hold a bachelor's degree or not. So the US STEM workforce consists of about 36 million people. And some of them do not have a bachelor's degree in science, but are still considered part of the workforce. Next one, please. Now, interestingly, foreign-born workers are a vital part of this S&E workforce. In 2019, foreign-born workers, regardless of whether they're US citizens or not, accounted for 19%, 19, of the STEM workforce. And foreign-born workers with bachelor's degree or higher accounted for 21% of workers in the science and engineering occupations at the bachelor's level, 38% at the master's level, and 45% at the doctoral level. So about 50% actually of foreign-born workers in the United States whose highest degree was in the S&E field were actually from Asia. And dominant among those were the Indians, 22%, and the Chinese, 11%, as their places of nativity. So clearly, US-trained science and educational doctoral recipients who are even on temporary visas at the time of graduation are a vital source of STEM workers. Next one, please. So this graph shows you the representation of male and female workers in occupations which employ more than 1 million full-time year-round workers. As can be seen, among those associated with women workers are the nursing profession and school teachers, whereas males predominate in being truck drivers, but interestingly, software developers are predominantly male. So they're in the top 5, whereas it doesn't show among the women to be in that category. Next one, please. So women full-time year-round workers earn a lot less than their male counterparts in almost any job that you can think of. So with the male and the purple being the female, you can see that in any of these job descriptions, the males always earn more. So that is part of what we call the pay gap. Next one, please. So in 2019, that is pre-pandemic, women made up 48% of all workers, but only 27% of STEM workers. So again, clearly an underrepresentation of women. And of these STEM workers, they were basically either social scientists or life scientists. So 48% women accounted for 48% of the life scientists and 65% of social scientists, but only 35% of physical scientists, 26% of computer and math scientists, and 16% of engineers. Next one, please. So here is a clearer view of where the women are in STEM, mostly biological sciences. Second in line are the chemists like you, some in the computer fields, which earn the most, and you see that they're not that well represented. Finally, you have the engineers here. Next. So this is the latest infographic from the Bureau of Labor, reflecting the labor force for both males and females. And you can see the dip here. This is a 3-year average. This is most likely due to the pandemic, which occurred 2 years ago. And there is some level of recovery, but not yet quite complete. Next one, please. So just like in any other job category, these are select STEM occupations. Women always earn less than their male counterparts. Next slide, please. So workers in science and engineering occupations, people have referred to this as the leaky pipeline, meaning to say they start out, with almost at parity with their male counterparts in the beginning, but as you climb up the academic ladder, the representation of women become less and less. And even in biological sciences where women outnumber men, loss of women as one ascends becomes more and more prominent. And although people say it's a leaky pipeline, others say that's more of a game of chutes and ladders where you can fall into a hole even after you've made some advancement. And in academic medicine, as you see here, they start out at parity, but only out of the 50-50 proportion of women, only 18% become hospital CEOs and 16% become deans or department chairs. Next one, please. Next one, please, Gladys. So that's the chutes and ladders representation. So in academic medicine, as you see here, 51% of the applicants to med school are women, 48% graduates, almost equal. But by the time you attain the senior leadership position, there are only a few women left, 18% out of the original 50%. Next one, please. And this is particularly dire if you are a woman of color. That's why they call it, intersectionality of gender and race. If you're a woman of color, particularly if you're Black, which is the blue number here, you can see that beginning with, even as an instructor, you have more whites, which are represented as violet. But as you ascend to full professorship, a very little proportion consists of Black women. They're mostly whites and some Asians. So the contrast is marked. Next slides, please. So things have changed for the last few years, and there is a French saying, plus ça change, plus la même chose, meaning say more things change, the more they stay the same. So right now, women earn more degrees. They have women role models. They have broken a lot of glass ceilings, and yet they still face the same discrimination, harassment, and prejudice as in years past. They still don't earn the same salaries. They still don't get the big lab space that their male colleagues get. And the COVID-19 global pandemic has disproportionately had a negative effect on women who bear the greater burden of caregiving and household responsibilities than their male colleagues. And the evidence suggests that the pandemic's impact leads to a lot of loss in productivity for women scientists, particularly those with caregiving responsibilities, whether they're young kids or caring for their parents. And compared to the 2020 numbers in February before the pandemic, women's employment is down by 9%, while men's employment is down by only about 7%. So we see that the women's participation in the labor force is critical for our future. Next slide, please. So last year, my office, which is the Office of Research on Women's Health, decided to take an inward look at ourselves and reflect on what is a gender equity in our own workplace, the NIH workforce in Bethesda. We wanted to compare also how many grants do we actually give to women versus men. So I'm happy to share with you the following results. Next one, please. Next one. So as you can see here, as of September 30, 2020, that was the last quarter of last fiscal year, there were about 18,200 individuals who comprised the full-time workforce of the National Institutes of Health. Of this 18,000 individuals, 59% were actually females. So that's good news versus 41% males. But the workforce was again predominantly white, followed by Black, Asian, and then Hispanics. Employees who identified as being 2 or more races, American Indians, and Native Hawaiian or Pacific Islanders, only constituted 1.8% of the entire NIH workforce. Next slide, please. So the workforce consists of 3 major occupations: scientific occupations, health and research occupations, and infrastructure occupations. Scientific employees directly lead or conduct basic or clinical research, provide oversight for research, both intramurally and extramurally. So if you're a biologist, a health scientist administrator, a medical officer, or a veterinary staff, you are considered a scientist. And usually your title is you're an investigator, scientist, clinician, medical officer, scientific executive, or program leader. On the other hand, health and research employees directly support the basic and clinical research conducted at NIH and are usually allied health professionals such as nurses, pharmacists, and technicians. On the other hand, infrastructure employees are those occupations that are not classified as either health and research and support the other occupations and include accountants. And as you can see here, in all job categories, whites were still the dominant race, followed by Asians, but only in the scientific occupations, and Blacks if you are in the infrastructure occupation or in the health and research occupation or sector of the NIH. Next one, please. So in scientific occupations, white was the predominant race, and 30% of those in this category were females versus 40% who were white males. Next among the scientists were the Asian males and then the Asian females. For health and research occupations, again, you have predominantly white, followed by Blacks, Asians, white males, and Black males. For the infrastructure, the largest group, again, was the white female, followed by Black females, white females, and then Black males. Next one, please. So white employees, now we are looking at senior leadership and supervisory employees. You see that senior leadership, again, is predominantly white, followed by Black, Asian, and Hispanic. And among those with supervisory status, again, predominantly made up of white employees. 70% of the positions were occupied by whites. Next one, please. Now, when we look at the extramural, so 20% of the NIH funds is for research being done in-house or within the NIH campus in Bethesda. The rest of the money is actually distributed to the rest of the United States, to all of the universities that apply for grant funding and are awarded. So when we look at the different grant mechanisms here, we have the research project grants, which consist of the traditional, what we call R01 grant. So that's the one given to the PI or the principal investigator to conduct the research. We have center grants. We have other research grants of different categories. The SBIR, STTR are the technology grants, which have to do with inventions, etc., and getting them across. And research career grants are actually training grants given to junior faculty in training. They could be advanced postdoc careers. And in all of these different kinds of grant mechanisms, you can see that the proportion of women is very much less than men. So it can be as low as 21% to the highest is 40%. The only time that you have more women than men, more than 50%, is for the training grants mechanism. So that's the irony of it. More women than men are trained and get this career development awards, but when it comes to funding your grant application, women get only about 30 versus 70 to males. Next one, please. So the R01 grant is the original and oldest type of grant mechanism, and it's usually you want to get one if you want to get tenure in the university. You have to bring your own money for your own salary. It's not like the Philippines. You are, paid for life as long as you're employed by the university. In many universities, nobody is tenured. You have to bring in your grant so that you can pay your salary. And this demonstrates the success rate of R01 equivalent grants. And again, so the percent of success is not very high. It's usually 20% or so. And it's mostly awarded again to whites. Next one, please. So from this analysis, we've seen that men consistently receive more R01 equivalent grants and research project grants than women. They outnumber women in almost all types of awards except the training grants. There are more men PIs than women PIs who have multiple grants at the same time. And women always are underrepresented in all the kinds of grant categories except for the training grants. So, but the good side is that women receive more average funding for their R01 equivalent grants and outnumber men as far as career development awards, pre-doctoral, postdoctoral, and K awards. Next one, please. So clearly, in summary, racial, ethnic, and gender disparities exist at all levels of the STEM workforce, and much has to be done to achieve equity, particularly for the STEM workforce, which is the engine of the economy. I'm sorry, I don't think this is the slide that I intended. Can we go to the next one, please? Yeah, that one, okay. So the NASM, or the National Academy of Science, reported so aptly that diversity, inclusion, and equity are required. And you have to have a sustained and intentional institutional commitment to this, to enable us to change climate, culture, and norms. You need to have committed leadership. You have to have data-driven accountability, and you have to provide tangible rewards, resources, and recognition. Next one, please. Okay, next one, please, Gladys. So with that, I would like to, with this overview, I'd like to thank you all for your attention, and thank you again for the invitation.
Thank you, Senia, for that very comprehensive and insightful presentation. So just to remind everyone, sorry, I didn't know that. Just to remind everyone, please, if you have a question, we will have a Q&A portion after all of the talks. So please write down your question in the Q&A panel or the chat, in the chat box. So we will now proceed to the next speaker. And I would like to call on Dr. Cheryl Ariola to introduce the second guest speaker. Cheryl.
Hello?
Hold on.
Oh.
Let me just stop. I'm sorry. I'm having a hard time. Okay, you can.
Okay. Thank you, Ma'am Gladys. Our next speaker is an alumna of the University of Santo Tomas, Manila, Philippines, where she took her bachelor's degree in chemistry. She then completed her Master of Science in Chemistry and PhD in Biology, major in molecular biology at the Bowling Green State University in Ohio, USA. She is also a former NIH postdoctoral fellow at the University of Michigan Medical School Department of Biological Chemistry, and currently an associate professor and the associate chair of the Department of Biological Sciences at the University of South Carolina, USA. She is also the director of the Mouse Experimentation and Noombiotic Core Facilities at the Center for Colon Cancer Research, University of South Carolina. She is also an active member of PAASE, where she headed the membership committee of the association in 2021. Indeed, she's a champion in understanding the complex interaction between tumor cells and its microenvironment to enhance the efficacy of current therapies or develop novel therapies to block tumor progression and metastasis. So ladies and gentlemen, let's all welcome Dr. Maria Margaret Tigner. Take it away, Ma.
Okay, so I think I need to share. Do you see my screen?
Yes, ma'am.
Okay, ma'am.
Oh, okay, so is it working now? Okay.
Yes, we just have to put in a presentation mode there. Thank you.
Okay, yeah. So is it okay? Okay, right. Okay, thank you very much. So first of all, I would like to thank the organizers. I'm very honored to be invited to this breakfast with very distinguished women. I'm very humbled to be around all of you. I'm the last person to think that I'm distinguished at all. So I'm very honored to be in your presence. And so today, what I'd like to do is share a little bit of my science and correlate it to my journey to get from where I started to where I am. And I do not really mean to be inspirational, but I hope that at the end of this story, you can find the path like I did, even though it was dark at many times. And so this is the title of my talk, which is My Science and My Unconventional Path to a Science Career. It Takes a Village. And so, let's see. How do I move this? Okay, so broadly, the research in my lab looks at interactions between tumor cells and the non-tumor cells in the microenvironment. And so this stems from the fact that tumors are actually made up of a heterogeneous population of cells. And each of these tumor cells may have different capabilities to initiate tumors, such as cancer initiating cells called cancer stem cells. And some tumors make up the bulk, some cells make up the bulk of the tumors, while other cells have the capability to invade the surrounding mucosa or travel to distant organs. And so studies on cancer have really identified what we call as the hallmark properties of cancers. And this has served as a framework. This was developed by Hanahan and Weinberg way back in 2000 and updated in 2011. And this provides the framework for understanding the properties of tumor cells that make them different from normal cells, as well as a framework to developing therapies based on the properties that cancer cells have. So what my lab is really interested in is the fact that in addition to the cancer cells in a tumor, it is also equally infiltrated by a very heterogeneous population of non-cancer cells. And this includes cells such as fibroblasts, endothelial cells that help to build the blood vessels within the cancer. And in addition to that, we have this myriad collection of immune inflammatory cells that communicate. So the cancer cells communicate with these cells to help the cancer cells grow. And this is what I call as taking a village to help tumor cells grow, because they don't do it by themselves. They actually talk to the normal cells around them to help them grow. And so studies over time have shown that these cells that infiltrate the tumor actually secrete molecules like cytokines, growth factors, and hormones. And all of this can activate pathways inside the cancer cells to help them gain growth advantage. And so the goal then of the research in my lab is to understand the mechanisms by which the immune cells in the tumor microenvironment promote tumor development, determine tumor response to cytotoxic therapy. For example, we look at response to 5-fluorouracil, which is one of the most common anti-cancer drugs, and promote tumor metastasis to distant organs. In particular, we're interested in studying the early phases of metastasis because it gives us the opportunity to identify biomarkers that can help to diagnose the cancers early, as well as identify targets that might be used to prevent the advancement of metastasis. So our work is focused on colorectal cancer, and this is because this is the third most common cancer, not just in the United States, but also around the world. And it's the second leading cause of cancer deaths in the United States and worldwide. So in 2021, approximately about 148,000 new cases were diagnosed in the US and 53,000 deaths were predicted, while worldwide about 1.9 million new cases were predicted and 0.9 million deaths were predicted for colorectal cancer. And very interestingly, about 12% of this incidence is colorectal cancer in individuals that are younger than 50 years old. This is called early onset colorectal cancer. And this is a growing epidemic globally, and nobody can actually understand why this is happening. And this has been increasing in the last few decades and is predicted to increase by 140% by 2032. So this is a growing epidemic. Now, the main cause of death in colorectal cancer is metastasis. And so one of the goals of the research in my lab, I'm going to share a short story because I can correlate this to the trajectory of my career. is to understand the difference between a poorly metastatic as compared to a highly metastatic cells. What makes the cells be able to travel to distant organs? So we used a mouse model to identify cells that are poorly metastatic. So these are called CD26 cells. If you inject them into the cecum of the mouse, they develop a tumor, and in 21 days, they will have metastasis to the liver. So what we did was we took this liver metastasis and then made a single cell suspension out of that, and then we passaged it 3 times through the liver of the mouse, and we were able to isolate this cell line called CD26FL3, which is 10 times more metastatic than the CD26 cells. So 90% of the mice that you give the cells to will develop tumors, and they develop very aggressive metastasis in the liver. So we wanted to know the difference between the highly metastatic versus the poorly metastatic cell. So we carried out a microarray analysis to look at the genetic programs that are driving the cells. And so we were focused on looking at cells that are involved in signaling, because we thought that these cancer cells will send the signals out into the microenvironment and recruit those cells into the microenvironment that can help them to grow. And so by focusing on this, we were able to identify interleukin 33 as one of the most highly expressed cytokines in the highly metastatic cells. And so when we put this interleukin 33, if we take the gene for that and express it in an even more poorly metastatic cells called MC38, what we found is that they made the cells grow faster. So now 5 of 20 mice will have a tumor growing if you just have the MC38. If you overexpress IL-33, 16 of the 20 mice will develop a tumor, and those tumors are much bigger than the ones without IL-33. When it comes to liver metastasis, we inject the cells into the spleen and then make it to the liver. 7 out of 10 cells will develop metastasis if you don't have IL-33. But all of the cells that get IL-33 expressing liver cancer cells develop high levels of metastasis. So these cells, this IL-33 makes the cells very efficient in colonizing what would have been a very hostile environment and allow these cells to grow in the liver once they arrive there. So interleukin 33 is a very small molecule. Typically, these molecules are secreted outside of the cells so that they can communicate to other cells outside of the tumor cells and bring them into the tumor microenvironment. But IL-33 does not go out of the cell. When it's made, it actually goes into the nucleus and it acts as a repressor. However, when there is the cancer and inflammation around it, or when there is necrosis, IL-33 by some mechanism leaves the nucleus and it goes out of the cell and then recruits all these inflammatory cells into the tumor microenvironment. When these cells get into the tumor microenvironment, these mast cells and neutrophils secrete what we call as proteases. And what they do is they take the full-length IL-33 and they cut it into smaller pieces. And in fact, the smaller pieces are 30 times more active than the full-length IL-33. So this is a way by which it becomes more effective. It's educating the cells around it to recruit more cells and help the tumors to grow once it arrives into the liver. And so basically, to summarize this very short story, the highly metastatic colorectal cancer cells that express high levels of interleukin 33 remodel the microenvironment efficiently to establish the metastasis at the distant site in what would have been a hostile environment, proliferate at the distant site, and promote blood vessel formation or angiogenesis by recruitment of pro-angiogenic immune cells into the microenvironment. So in short, these traveling cancer cells that go to the distant sites have packed within their luggage the tools that they need to survive and colonize that distant organ. And so I tell this story because this is my science, of which I am passionate for, but it also reflects my journey from my hometown to where I am now. So I come from a town in Bukidnon, up in the mountains, amidst the Del Monte pineapple fields. That's me when I was 2 years old. And here I am now at the University of South Carolina. I'm an associate professor. I recently became associate chair in this famously hot city of Columbia, South Carolina. How in the world did I get from here to there? How did I metastasize from Bukidnon to Colombia? And so what I can say is that there was a very potent catalyst that started this whole reaction. And that catalyst was this Time magazine issue that came out in April 16, 1977, when I was a high school student in the little town of Bukidnon. And so there were two stories on the cover of this magazine. I could have read A Day with Jimmy Carter, and that would have propelled me into a career in political science. But instead, I read the article about the DNA Führer tinkering with life. And so the article was about genetic engineering. It talked about how the scientists can now clone genes, put them into organisms, make mutations in the genes, basically tinker with life. Oh, it was so exciting for me that I said, I read this, I actually read this twice. This is one of the magazines that my dad probably picked up from the break room of his work. And I said, that's what I want to be. And of course, it comes with these fluorescent pictures of DNA in a test tube, which makes it even more exciting to look. So I said, I'm going to be a biochemist. Of course, I had no idea how to become a biochemist. Everybody wanted to be a doctor or a lawyer or a teacher or a nurse. Nobody wanted to be a biochemist. But yet, I'm like, well, maybe I'll figure that somehow. And so looking back, if I look at my life, it looks like the Wizard of Oz. All of these friends traveling the yellow brick road to get to the Emerald City in this line that goes straight up to see the Wizard of Oz. So I could compare my journey in science similar to this, except that there are lots of twists and turns, as what our Dr. Koo said. Our roads may not be straight; it may have a lot of turns. And so this is the yellow brick road, and I could call my journey as the long and winding yellow brick road. There were some beetles interspersed into that. And so along this yellow brick road, there were a lot of pivotal moments, twists and turns that I never expected, but then they pointed me in the right direction unknowingly. So back when I was in high school, my best friend's uncle was a doctor. And every weekend, we would go with him to the barrios around Phillips Bukidnon, and we would give out medicine to the people who had no access to clinics. They paid us with kamoteng kahoy, and all of that, and we were happy to eat those with them. And my ambition was to become a doctor. But then my family was poor, and I was the oldest child of 8 children. So that dream was dead on arrival. No way my parents could afford to make me a doctor. But then I also had a high school guidance counselor at that time. And so our guidance counselor told us that, in life, you will always be taking exams. You will take the board exam, you will take the civil service exam. In fact, in order to go to college, we had to take the NCEE exam at that time. I don't know if that's still true these days. And so she told us that you need to have practice taking exams. So she said, there's this NSDB scholarship exam. You should go take it. But I warn you, it's one of the most difficult scholarship exams. So just take it for the experience, but do not expect to pass it. So being high school students, we're like, hey, we get to go to Cagayan de Oro. That is the city that's 45 minutes away from the mountains. So we have to travel the winding road to Cagayan de Oro. And said after the test, we can go watch movies, go eat in a restaurant, eat ice cream. That should be fun. So we went and took the test. We slept in the attic of my aunt. We went and watched the movies, took the test, and forgot about it. So we graduated from high school. I was actually the valedictorian then. I had no idea what to do with my life. And so it was decided that I should become an accountant. And the reason for that was one of my uncles just stopped the CPA exam, and therefore I should follow in his footsteps. So, okay, I will become an accountant. I will go to the University of San Carlos in Cebu and start my career. Well, life had other plans. The day before I was supposed to leave for Cebu City, the only neighbor that had a newspaper subscription in our town came running to our house. This was the afternoon, and he said, hey, look, you passed. So we took the exam in November, and this was sometime in June. And I said, what did I pass? And he said, you passed the NSDB scholarship. And I said, really? So all of us, my friends and I, ran all the way to the other side of town and told my guidance counselor, ma'am, I passed. And so this is a pivotal moment in life because it completely changed the direction in my life from being an accountant into starting my journey as a scientist. So I passed that. I went to Manila instead of going to Cebu. But then I had not taken any of the entrance exams, and no college would take me because it was too late. So the only college that would accept me was the Philippine Women's University. So I have the distinction of being the first NSDB scholar to go to Philippine Women's University. I enrolled in BS chemistry because I was very close to biochemistry. And so after 1 year, I wanted to transfer to a different school. I heard that students who were chemistry graduates of UP and UST did very well in the board exam, so I should transfer there. Well, my uncle and aunt, who were very religious, said, you cannot go to UP. There are a lot of radicals there. You should go to UST. They're Catholics. I'm like, well, anyway, UST was my dream school. So I said, okay, I'll go to UST. So every month I would go to UST and apply to transfer. And every month the secretary told me, come back next month, come back in September, October, November, come back in March. So I came back in March, and then he told me, well, we're closed. We don't take transfers anymore. I was totally devastated for the first time in my life. I went down the steps of UST and I was crying because my dream was shattered. I'm like, all I wanted to do was transfer to my dream school, and I can't even go there. So halfway down the stairways from the third floor, probably the ghosts of UST were encouraging me. They said, go back up there and to talk to the secretary. So I marched all my 70-pound self up the stairs. I went to the dean's office and I told the secretary, you really should accept me. I'm a very good student. I got an A in my chemistry and I'm an NSDB scholar. You'll be very happy to have me. And the secretary would have none of it. No, everything's closed, go away. The dean already shut down the application. So I told him, well, I want to talk to the dean. I want the dean to tell me no. And he says, well, the dean's not accepting visitors. And so I told him, well, I'm going to stand here until the dean sees me. So of course the dean was just in the next cubicle and he could hear all this commotion. So finally he said, okay, go see the dean, just to get me out of his path. So I went inside and explained to the dean, Dean, you should accept me. This is Dr. Mariano Pangan back then. So you should accept me. I'm a very good student. I'm hardworking. I have a scholarship. You'll be happy to have me. And so the dean looked at me and like, are you the cause of all this commotion? He said, yes. And he says, okay, you're accepted. That's all he said. And so just like that, I became a student at UST. So I was at UST as an NSDB scholar. Actually, shout out to Julius. I actually did an internship at the Philippine Textile Research Institute. It was very exciting for me because we just bought our instrumentation at UST and nobody wanted us to touch it because we might destroy it. But then when I went with PTRI, they actually let me do analysis on the mass spec, the IR and all that. So it was a very nice experience for me. So I graduated. It was a very tough degree. I went home for 2 weeks to take vacation. When I came back to study for the board exams, my classmates were telling me that, hey, the dean is looking for you. And I said, well, I definitely cannot be expelled if I got into trouble because I already graduated. So I went to the dean and said, hey, dean, I heard you were looking for me. And the dean said, well, you have an interview on Thursday. I said, what interview? I didn't apply for anything. Oh, yeah, we have an opening for instructor, and so you should be good for it. So go ahead and show up for the interview. I said, but I didn't apply. And he goes, well, I applied for you. So go do the interview. So I presented the talk. He said, go present a lecture in general chemistry. So I did. And that's how I got hired to be an instructor at UST. So after 2 years later, one of my friends came by and said, hey, he was working at San Miguel. He said, you should apply for graduate studies in the United States. And I said, what's graduate school? What do you do in grad school? And he said, no, you go get a PhD and a master's. So we went to the East-West Center on Rojas Boulevard and applied to all this university. And I made it to graduate school at Florida State University. When I got there, all that they did was give us exams in physical chemistry, which is really not my strength. I'm like, I'm just a failure here because I really cannot do physical chemistry. And so I was dejected, applied to other schools. I got accepted to the University of Houston. I had relatives there, so I said, oh, maybe I should go there. But along the way, I met this debonair statistician from the University of Los Baños. And so he stole my heart. So instead of getting a master's degree, I decided to get a marriage degree and I married him. And actually, he said, no, we cannot get married. I'm too young. I'm like, well, we either get married now or I go away, and that's the end of us. So we ended up getting married. We ended up having 2 kids, 2 girls, And so this is where you get into the crossroads of my life and said, well, do I pursue a career in science or do I go back to being an accountant? Because I have 2 kids and I got to take care of them. So I tried my best to become a good accountant, and it just was not who I am. I was not happy. So I told my husband, I woke up one morning and I said, I'm going to go back to science. And so I'm a very good, supportive husband, and he said, by all means, go back to science. And so I told him, well, that means you're going to have to wash the dishes, wash the clothes, help with the kids. And he says, oh, I'm perfectly fine with that. And so I got my master's degree in chemistry at Bowling Green State University. I have a chicken here because my project was looking at developmental regulation of chromatin structure. And our model was the beta globin gene. The embryonic globin gene is expressed during development, but as the chickens mature at 11 days old, they switch to the adult globin gene. And we're looking at the chromatin structure during the switch. And so basically, I spent my life collecting blood from these little ballots. We would go to Ohio State University, take 24 dozen eggs, and literally spend the entire day harvesting eggs from these ballots. And then we'll take this chicken, give them to the guy next door, the next investigator, and he would crush them in the blender and isolate top isomerize from the cells. So I got my master's degree, but the only PhD program in Bowling Green State University Department of Chemistry was in photochemical sciences. And there was no way that I was going to take another physical chemistry course. So I went to the Department of Biology, where I took my PhD in molecular biology, looking at stress responses in photosynthetic bacteria. In nature, bacteria go through this feast or famine state. And so we wanted to see how they adapted to nutrient deprivation. So in this case, I had this 35-gallon jars. I would grow my bacteria in them. If they're healthy and replete, they will be dark green. If I starve them for nitrogen, they become yellowish. So the color will tell me when I can start my experiment. And I will harvest this all day, break the cells open. And we then identify the cells called DPSA, which actually forms a core around the DNA and protects the DNA from damage from oxidative stress during nitrogen deprivation. So then came another crossroads. When I finished my PhD, all of my colleagues were applying for postdoctoral fellowships. They were going to places like Harvard, the NIH, Johns Hopkins. In the meantime, I'm here in little old Bowling Green, not knowing what to do because my husband at that time was already a full professor at Bowling Green State University. And so my husband, who was ready for sabbatical, said, well, I'm going to Michigan. So maybe you can apply for a postdoctoral fellowship there. So I said, okay, fine. I'll just do a 1-year or 2-year postdoctoral fellowship, and then I'll be done and figure out what else to do with my life. So I wrote to one of the professors there, Dr. Danny Steele, who was one of the premier professors, the leader in the field of copper metabolism using yeast as a model system. And of all surprises, he gave me a postdoctoral fellowship. And then we decided that I should apply for an NIH postdoctoral fellowship. And we're like, okay, fine, we'll do it. And so before I even got there, I applied for this. And lo and behold, I got the NIH fellowship. So the 2 years became 5 years, and my husband was driving back and forth between Ann Arbor, Michigan, and Bowling Green, which is a 70-mile drive, winter, spring, summer, and fall. So I really owe my husband a lot for the support that he gave me throughout this process. So by the time I finished my postdoctoral fellowship, another crossroads come. I need to apply for a faculty position or figure out what to do with my life. So here comes the two-body problem. My husband had a position at Bowling Green State University, but they will not accept their graduates as faculty members there. In addition to the two-body problem, I also was diagnosed with a brain tumor, and I'm like, now what to do? Maybe these are the gods telling me to stop this and go in a different direction, go back to being an accountant. But then I survived both of this, and then my husband got recruited to the University of South Carolina. So when I got to South Carolina, they really wanted to recruit my husband. So they took my CV and gave it to the biology department and said, here, look at her CV and see if she belongs to you. And the department chair said, hey, I have no problems hiring her as a tenure track assistant professor. At that time, I had just gotten out of brain surgery. I didn't know if I was going to live. I didn't know if metastasis was taking place. So I'm like, it would not be fair for them to invest in me $500,000 only for me to disappear and die on them. So I'm like, what are my other options? So my director chair said, well, you can work as a research faculty in my lab. So I said, okay, fine, I'll do that. So I became a research assistant professor in my professor's lab. At that time, so this is where all of the opportunities come in that you never expect. At that time, NIH initiated what they called as the Centers for Biological Research Excellence, which is targeted to a few states in the United States. And we applied for one of these programs. It's about $11 million for 5 years, which the goal for this is actually to develop faculty that can be funded with R01s, R01 funded faculty. And we established what we called as the Center for Colon Cancer Research. And during this time, they needed someone with a PhD to run the core facility, the mouse experimentation core facility. Well, I had a PhD, but I was a yeast geneticist. And I'm like, what do you want me to do with mice? They have tails, they have teeth, they bite. And so they said, well, you have a PhD, you know? And I looked at them and said, okay, fine. A mouse is just a yeast with tails and heads and everything. All the processes are conserved. It's a novel motor organism. I'll be the director of the mouse experimentation core. And that was the history. It actually became one of the most used cores. It was a model core that was used by many investigators and launched the careers of many investigators. And it established a lot of collaborators through there. And to this day, I still direct the core and added the notobiotic facility to that core. The notobiotic facility allows us to work with germ-free mice to look at the role of microbiome in many diseases. And so during this time, we had a new provost at our university. So I got funded through the COBRA. The provost that came to our university actually ended up being a statistician who owned the house that we rented in Michigan. And our story is that our hamster actually ate a hole in his bathroom. But anyway, when he came to the USC, he established what is called the Center for Research, a centenary research professorship, wherein they give you a startup money of about $150,000, pay 3 years of your salary, and then give you an independent lab. And so I was nominated for this and luckily got this. And so what that allowed me to do was I could now apply for my own R01 grants. These are the R01 grants that Senia was talking about because I had an independent lab. In addition to that, part of the CCCR, the Center for Colon Cancer Research, was to fund target PIs, where they give you between $100,000 to $150,000 a year to strengthen your research so that you can apply for an NIH R01. And so within 2 years, I was able to convert my funding into an NIH R01. Now, unfortunately, with all that success story, what happens is that I was still a research faculty. And literally my contract says that if I run out of funding, they only need to give me 2 weeks of notice and I'll be out of a job. There was no job security at all. And so I decided that I really wanted to apply for a tenure track position. Well, the dean said, it doesn't matter that you brought in $26 million in the COBRA or another $1 million for your own research or millions of dollars by working with other people. You need to compete at the national level and rise to the top in order for me to hire you as a tenure track faculty. So at first, they didn't even want to interview me, but my department fought for me. So this is where your village comes in. When they believe in you, they can actually fight for you. If not, they'll just forget about you and pray that you go away. So anyway, they fought for me and the dean said, okay, fine, I'll interview her if you want her. So they interviewed me. I gave it my best effort. My chair came to me, don't screw this up because this is your future. So I said, okay, fine, I'll give a good review. And a part of the interview process is giving a chalk talk where you describe your future research. I did my best to do that. And so eventually the department voted to hire me. And so when it got to the dean said, well, it's not gonna look good if you hire her as an assistant professor. After all, we require our assistant professors to get an R01, she already have that. We require assistant professors to get publications, she already has that. So if you really want her, I'm gonna hire her as an associate professor with tenure. And so they came back to me and said, hey, here's what the dean says. She wants to hire you as an associate professor with tenure. And I said, of course I'm not gonna say no. I'm not crazy enough to say no. And so that's how I got to be a tenured associate professor. And so that dean gave me the appropriate salary equivalent to everybody. They thought she would just give me a low salary because I was cheap. I was already there. I'll take anything I can get. but she actually gave me what was commensurate to an associate professor at the Margaret level. In addition to that, even though I had my independent lab, she actually gave me almost $500,000 in startup money. And so, you know, this is one woman and understanding the challenges of another woman. And so all the males were looking at me like, wow, I can't believe she gave you that. I'm like, well, she's a woman, she understands me. So anyway, that's how I got to be. So in my category, she's the best dean in the whole world because she gave me the opportunity that I have. And so I'm really grateful to my department for giving me this opportunity. And I've gave back in so many ways. As soon as I've been chair of so many things. And just this year, my chair, who is also another woman, asked me to be her associate chair. So our department really runs on women power. And so that's very associating. So the lessons learned here then, which I can share to all of you, is travel through life with the right cargo. Just like that metastatic cell who carried interleukin 33 so it can conquer this hostile environment. Travel with the right cargo. Know your science, be good at it, be collegial and collaborative so your village will fight for you when you're in trouble. Be grounded. And this is something that my postdoc advisor always told me. Be grounded but prepared to move in any direction. Work very hard, but don't forget to have fun and love what you do. Because after all, if you love what you do, getting paid to do it is just the icing on the cake. So with that, I want to quote this Jennifer Doudna, who got the 2020 Nobel Prize in Chemistry. And what her advice is that it means that you need to go for it all the way. Embrace your interests and your passions and really give it your all. The most successful people are the ones who conquer their fears, find supportive mentors, and I was lucky enough to have a lot of that as I went along. And if you have a good idea, work for it, because it's probably going to work out. And so with that, I'm going to thank the people. This is the view from my lab in the afternoon. Thank the people that joined this journey with me. These are my grad students, my postdocs, my technicians, the mice who I'm not sure they gladly gave it, but gave up their lives to make our research happen. The funding agencies that gave us the money to do our work, and the outstanding core facilities that allowed us to make our science look like art. And so this is the yellow brick road again, the long and winding yellow brick road. There's my family. That's my husband pointing at his name in one of the conferences. My daughters are now grown up. I'm ready to be a grandma. These are my mentors. These are the other men in my life. This is my PhD advisor. When he believes in my idea, he will bet his shoe. But if he thinks that it doesn't work, he will bet his house. This is my postdoctoral mentor, Dennis Steele, my mentor and director of our facility, Frank Berger. All of them gave me the ability to perform my research with independence and pursue my ideas in their lab. For that, I'm very grateful. I'm also grateful to meet all the colleagues in PAASE. They are very inspiring. This is my first PAASE APAMS meeting at NC State. I came out from that meeting completely inspired, in awe of the achievements of all my fellow countrymen. This is our picture with the Nobel laureate Smithies. There's Xenia right there next to me, the first time I met Xenia. And then these are one of the many, many Zooms with PAASE. And then there's all my friends who don't understand science, but just let me do what I am. And then these are all my students and undergrads throughout the years. And that's all I have to say. And that's the University of South Carolina. And I thank them for making it home for me for the last 20 years. Thank you very much for the invitation.
Thank you very much, Marge. That was so inspiring. Oh my goodness. Congratulations.
Just do it.
You were all in awe for what you have achieved. Oh my goodness. You are very blessed, and because you really work hard. Thank you.
Well, in fact, I pinch myself every once in a while and say, is this really true? Am I really here? So thank you for all the good things.
Oh my gosh, it was, I hope all those young chemists there got inspired from Marge's story. So please feel free to write down your questions for the speakers, for Xenia and for Marge. And now we move on to the next speaker. Okay, so let me just introduce our third speaker, Dr. Christina Binac. Hold on, let me just share her. I hope I can share. Sorry, I'm having problems here again. Okay. Right, so let me just introduce Dr. Christina Binac is a professor at the Department of Chemistry, the University of Santo Tomas. She finished her BS Chemistry degree at University of Santo Tomas and earned her PhD in Chemistry at the University of New South Wales in Sydney, Australia. She is currently the lab manager of the UST Analytical Services Laboratory. She was a Fulbright Research Fellow at Pennsylvania State University, USA. She was also a recipient of the Outstanding Achievement Award in Chemistry by the National Research Council of the Philippines in 2014, and the 2001 Outstanding Young Scientist Award in the field of chemistry by the National Academy of Science and Technology. Dr. Binac also held several leadership positions in professional organizations, such as the president of the National Research Council of the Philippines and as vice president of the Science Council of Asia. She is also a member of the technical panel for nanotechnology and of the technical panel for advanced materials of the Philippine Council for Industry, Energy and Emerging Technology Research and Development of the Department of Science and Technology. She is also the Philippines expert representative to the ISO Technical Committee on TC229 nanotechnologies. Let us all welcome Dr. Christina Binega.
Maraming salamat, Gladys, and magandang umaga at magandang gabi sa inyo lahat. Let me share my screen now. All right. Okay, let me move this a bit and all right. Muli, no? A pleasant good morning to everyone, and I'd like to thank our sponsors, our organizers, no, led by Ms. Gladys and the rest of the PAASE officers and all the other co-sponsors. So I'm Christina Binega from the University of Santo Tomas. Let me move this. Why is this not moving? Okay, there it is. Let me start with the end. All that I will be sharing with you are driven by my mission. How do I define my mission? Let me unfold my journey. This could be our journey, your journey, my research journey, my life journey. It will always have a start and it would always have an end. And because we know where we are heading to, then whatever happens between the start and the end could be our lifelong learning. Oops, hang on, why is it? Our lifelong learnings, it could be memorable. There are so many painful and joyful events that would be part of this journey. My journey started with my high school. I did my high school in the province, in Tarlac, and this is where I started loving science, specifically chemistry. It is with my high school teacher, Sister Crisanta Lugay, a Holy Spirit teacher. She made many, many experiments for us. She would boil colored solutions, and it would give us colorless solutions. So it's the permanganate distillation. She would take a piece of material from a bottle with oil and throw it in an aluminum basin, and we have loud explosion. So it was sodium metal. And she would extract perfume from ilang-ilang. This was lots of fun and magic for me. And I realized I want to take chemistry as my undergraduate degree. Along my journey, I encountered a number of forks on the roads, crossroads. Let me relate to you 3 crossroads in my research life. The first crossroad was a marriage proposal that came after I received my scholarship grant. So would it be the scholarship at the University of New South Wales in Sydney or marriage? I got the scholarship from the Australian International Development Assistance Bureau, ADAB, through NEDA Philippines. It will be my first international trip, so the excitement is very high. And it would definitely advance my career. And if I finish this program in UNSW, then I'll be able to share more with my students and colleagues. And after listening to the words of wisdom of my parents, then I chose scholarship over marriage. As my journey continues, I met another crossroad, and it is my research topic at UNSW. Will I take electrochemistry, wherein I am very familiar with working on chemical sensors and biosensors, or will I take surface chemistry as my topic? Finding a supervisor to guide you for the PhD is another problem. So will I choose a very eminent electrochemist, the late Professor Peter Alexander, or a new blood, Professor Robert Lam, who is a surface chemist and physicist? So I said, I'm very confident in fabricating chemical sensors and characterizing them. So I've been doing it at USD before this scholarship. Surface analysis for me is a new topic. The instruments are new and very expensive during that time. So I'm dealing with X-ray photoelectron spectroscopy and the time of flight secondary ion mass spec. My question now is, yes, this is a very hot and interesting topic, but can I bring this high-tech knowledge back to the Philippines? That would always be my question if I'm looking for a topic for my PhD, because I wanted to make sure that I'll be able to share this knowledge to my colleagues and students. And the answer was yes. So I marry both topics, the chemical sensor and the surface chemistry of sensor, to understand better what's happening on the surface of the chemical sensor. As I continue on my PhD journey, I got married, and on my third year of my PhD, I had a baby, and I took a leave, then went back to the lab. But this was very, very difficult. But I always kept my goal in front of me, and that is to finish the degree and go home back to Manila. Not long after, I felt I have reached my saturation point. I could not go anymore. I could not focus to my work. And I just want to go back to Manila. I'm just okay with my master's degree. Forget about the PhD. I just don't want to continue anymore. I told my husband, let's pack up and go back home to Manila. But I needed only my supervisor's endorsement so I could terminate my scholarship with ADAB, earn a master's degree, and go home to Manila. But Professor Robert Lam was saying, you only have few more details lacking for your experiments for a PhD degree, but you have too much for a master's, too much data for a master's degree. So I am now on my third crossroad, whether to take and be contented with a master's degree or continue pursuing for a PhD degree. In the end, it was my husband, Arman, who made me decide to stay. He was my strongest ally. So go for a PhD in chemistry, he said. What a waste, the sacrifices that we made for 4.5 years for my quest for a PhD. And you are very close to achieving your goal, he would say. It's just a hand's reach away from my dream, from our dream. The decision to stay was good, but it's the most painful decision that I think we made as parents, because when my mother came to visit us, he brought my 8-month-old son back to Manila with her so that I'll be able to focus in the last year of my PhD program. But I said to my mother, I would be home in 6 months. I promised that. But again, it took me a year to be united with my son. The year that I spent finishing my doctoral studies proved acutely heart-rending for me and for those I love. So the dissertation that I wrote month after grueling month, with no thought beyond doing the work well, so I could go home and make my family again. My son in 1997 is now 28-year-old, and he has a master's in biology. So I think I was able to nurture him well to go into science. I'd like to share with you the quote from Paulo Coelho, the alchemist. No? He said, "Before a dream is realized, the soul of the world tests everything that was learned along the way. It does this so that we can, in addition to realizing our dreams, master the lessons we've learned as we move toward that dream." True enough for this statement of Paulo Coelho. It's amazing how, in the midst of the most unbearable tests, our spirits do rise and meet the challenge. The crossroads, the three major crossroads that I had, demand from us that we are and as nothing less than our life's dream. I am truly grateful that I have been given a singular dream and mission. I'm also blessed with a family empowered to bring the dream to reality. And these are also some research experiences that I had, which I bring back home to Manila to share. My Fulbright visiting scholarship in 2006 with Professor Thomas Malloch. And it was the first time that I was able to optically see the nanorods that I made up of conduct gold, which are the yellow parts. This is a singular nanorod of gold. Conducting polymer is the black one, and the yellow ends are the gold. And these are nanosensors for gases. And these are bundles of these nanorods. And these are experiences that I brought back home. And now we're working on fabric supercapacitors, fabrics made up of abaca fiber, banana fiber, pineapple fiber, or water hyacinth fiber. And we made electrodes coming out from these fibers. And we have series of these supercapacitors as energy storage devices that could be powered using solar and could light up a circuit. And it could light up small devices like PC card, portable media players, flashlights, or even our oximeter. So low power devices. And also it could light up our flashlights, no? So we are able to prepare these fabric supercapacitors as rigid devices or as flexible devices that we connect in series or even in coin cell packaging. These are my research team for the NICER project of this fabric supercapacitor. UST has been one of the NICERs, the niche centers in the region for R&D. And these are very young members of the research team. My mission, of course, is to teach, to nurture, and to share. Thank you very much for your attention.
Thank you, Tina, for that very inspiring talk. Yes, you had 3 crossroads, but still you are very successful and you have all these accomplishments. Thank you for inspiring our young chemists here, young aspiring chemists or biochemists or biologists. So we will now move on to the last speaker. And for those of you who have questions for Dr. Tina Binac, please write it down on the Q&A box or in the chat box. I would like to call on Dr. Cheryl Ariola to introduce now the last speaker.
Thank you, Ma'am Gladys. Now, as we continue celebrating the accomplishments of women in science, thereby inspiring younger generation to pursue careers in science, our next speaker belongs to a very young age group, the millennials. She is an alumna with a strong background in chemical and biochemical engineering. She finished her Bachelor of Science in Chemical Engineering at UPLB and Master of Science in Chemical Engineering from UP Diliman with upper or first class honors. She is also a former faculty member of the Institute of Chemistry, UP Los Baños. Our speaker holds several master's and doctoral degrees and trainings from Harvard Medical School, Cambridge University, Oxford University, and Harvard Law School. Currently, she is a research fellow at the Harvard Medical School and a VOSTPC HRD Balik Scientist Award. A multidisciplinary scientist advocating the use of biosensors in medical science. Ladies and gentlemen, let's all welcome Dr. Jalik J. Forrest.
Hello, everyone. Thank you, and good evening and good morning to the people from the Philippines. Hello. Thank you so much for this invitation. I'll share my screen for a short PowerPoint. I'm really overwhelmingly inspired by the Filipino scientists, the speakers before me, who have quite accomplished a massive impact that could help a lot of Filipinos and a lot of women in science. So my journey is quite short and young, I would say. So I have yet a lot of things to learn, and I wanted to focus more on how I moved from basic research to clinical research and what motivates me to do these things. I hope everyone can see my presentation. So the topic that I actually thought about is basically the very reason why I went into engineering and why I moved from engineering to clinical medicine or clinical sciences. And it has nothing to do really with majority of love of maths or love of physics or love of chemistry. I do love these courses. And so this is just to inspire the young ones there that I did indeed love learning. But more than that, what really pushes me really hard is to basically make a better life for the people around me, for my family, and for the rest of the community. So I taught at a very young age that, you know, chemical engineering could be one of those degrees that I could take and make an impact eventually. And this is coming from Bicol region. And during that time, I know we were having lots of issues about people afflicted by mining. And during my high school years, I thought what could possibly be done to avoid people dying and people essentially getting really sick from the mining in Rapu-Rapu, which is like an island in Legazpi. And one of my professors in high school is a very inspiring person who motivated us that chemical engineering could make an impact in developing ways to make mining more sustainable and more environmentally friendly. And so from the very start, my motivation is to actually what is needed in my community, what could possibly be done, or what could I do, what education and training could I do to better the quality of life of my family and the very people around me. So that has been my motivations ever since. And so I would basically just run you through the journey that I went through, the challenges, mostly the challenges of how it is to obtain higher education or to even just get education from people who probably have a similar background as I do, or even far worse background that I did. So, yeah, so I wanted to show one slide of a photo of me. This was taken like 20. I was 20, I think. So this is like 15 years ago, and this was the very first time that I went to Stockholm. My professor invited me to attend the Nobel Lecture Series in Stockholm. And so I was there. I was quite impressed by the talk. I was inspired. So when I entered UPLB, at the back of my mind, out of curiosity, I wanted to study either the brain, how we understand things, and hopefully help with gaining understanding of how can we be less selfish, less greedy, like the neuroengineering processes, the neurochemical processes of the brain, and how we can motivate ourselves to actually use that education to help other people. And I thought understanding basic sciences by taking courses like hardcore chemistry, physics, biology, and even engineering could help us possibly develop ways into improving our behavior or improving the quality of life by improving behavior, things like that. So I was so fascinated. It's my brain was all over the place, like looking into Nobel laureates, talking about physics and chemistry. And this inspired me. This is one of the, I would say, ignition, the moment wherein my curiosity peaked through my science career. But this is just one part of it. When I look back now, I thought, yes, Nobel lectures, Nobel series, and amazing people, brilliant, extraordinary mind. Yes, it ignited my passion for science and learning, but in the long run, it didn't really make it sustainable. To be fascinated by accolades and brilliance of mind is one thing, but what use is an extraordinary mind if the heart is not as brilliant as the mind? So I thought we need to move from basic sciences. Yes, basic science, we could discover everything. We could understand a lot of things, how the world works, how we understand, how we conceive the universe, the theory of how the universe started, all these things. Yes, it's fascinating, it's amazing, it's fundamental. It inspires us, the very being in us. But to push me from continuing this learning, it's not enough. The basic science is not enough. It has to do something. And one thing that Alfred Nobel, the man who established Nobel Prize, have in mind is very similar to the motivation I had when I was a child. Make science be useful to mankind. And in order for me to move forward to being useful in my own community, I struggled with moving from basic sciences to actually developing enough credentials to move to applied sciences. And as you know, and as the previous speakers have told you, it's difficult to actually, for female scientists to actually move from this stage, knowing that, the arena of engineering and physics is still a male arena. So it has been challenging to start with, dealing with engineering and physics, and then moving from there, going to clinical medicine. Majority of the doctors are still male. And so, yes, basic science is a good inspiration, but a motivation for me is empathy, having to look into yourself and, Maslow's self-transcendence, ask yourself, what could benefit my community? What could I do to help and support my community and at least be part of the solution? And so I moved from basic science to translational research, and I would go through what I've done the last couple of years with my career. So like I said, I started with basic research. I thought I could do either neuroengineering or physics, understanding the world around me, or understanding my own brain. And I started with research on neuroscience. So this particular research is the one that I did in Cambridge, wherein we're trying to develop or to understand how clinically healthy neurons communicate with other healthy neurons, physiologically healthy neurons, and then eventually try to understand how does a pathological neuron actually communicate with another neuron. So that's a basic research, a fundamental question of how are they communicating? What are the molecules that are used to transfer from one neuron to another as a form of communication? can we actually observe single neuron transmission? So how does pathology affects the way the other neuron communicate with a physiologically healthy neuron? And what are the chemical and potential sensing that could be done? So this is the basic research that I did at Cambridge, wherein we're developing microfluidics technology coupled with high resolution imaging to understand how neurons communicate. And that's a fundamental question. So what can we deduct from this? What can we understand from understanding the single neuron communication? And how can we apply this into understanding pathological mechanism, pathogenesis? How could we understand neurological disorders eventually? So how can we understand Alzheimer's, for example? So from basic research of developing understanding on fundamental communication between neuron to neurons or neuron to pathological neurons, I moved to translational research. So we did a lot of multidisciplinary research wherein we actually started developing microfluidics devices, technology that could further culture or make it three-dimensional. So now from observing cellular or at a cellular or molecular level, we move to something bigger. Like, let's see what happens when you apply optics or light and you triggered some communication or molecular or electrical or you trigger using photons. What happens to rats, for example, or mice? How can you control the signals inside their brain? So that's one animal research that we move forward to from starting with microfluidics with basic research. And this is just an example of the microfluidic device that I developed. And this is actually a photo of a single neuron. So if you can see the transmission, so these are molecular transports of neurons. So we can see that you can have single axon inside the chip. So basically trying to understand how each axon is connected to the other and then how they start communicating. So neurons and their communication with other neurons. And then, so I moved with translational research. Translational research, so we started with animal models, but eventually we wanted to do human models. So this is when I moved back to Harvard. So I started working with developing like stimulators for vagus nerve, for nerve endings, for peripheral nerves. And this is just one of the simulations that I did wherein we have some sort of, we call it a micromagnetic stimulator where you could expose your peripheral nerves and it causes nerve endings to basically respond to that magnetic field and magnetically being converted to electrical field. And so the way that I explain this to my nephews who are very young is that essentially we're trying to understand or develop something of something like Magneto. I'm not sure if you're familiar with this, but I'm a Marvel fan, so Magneto and X-Men. So this is how I describe this to my nephews when they ask me, oh, Tita, what are you doing right now? So I'm trying to explain to them that, you have nerves, and if you've seen X-Men with Magneto and Professor X, we're trying to actually develop a non-invasive way to stimulate the brain. And the application is basically for children with epilepsy or people who has drug-resistant epilepsy. So this is the translational research that I did at Harvard. And this is just to show you what I've been doing. This was like 2 years ago, 2 years ago. And then that translational research was then moved to a more clinical application, which is basically from bench to bedside. So this is what I wanted to talk about, like the struggles of actually moving from a basic research to translational research and moving forward to a clinical research. Clinical research meaning bedside, wherein you move your basic advances in sciences, technological advances, development of new devices from the laboratory scale, from your bench scale to bedside, where the patients or the communities actually needed it. So this is just an image from Neuronics. Neuronics have I think this was announced very early this year that they managed to start developing a stimulation device that could help with Alzheimer's. So so that's what I've been, well, that's essentially my journey. So how I move basic research to clinical, to translational research, and now doing clinical research. And the struggle that I was talking about is not just being a female scientist, but also being a people of color and dealing with these challenges, you know, in countries that you don't really know about. I'm from the Philippines. I was born and raised in Albay. I went to UP for my undergrad. But then after that, through the help of great mentors from UP, I would just give a shout out to Professor Ernesto Del Rosario, because he was the one who actually told me to move out of my comfort zone and start looking into my career outside of the Philippines. So when I moved to the US, it's very challenging for me, and it's even more challenging, I would say, because you know, coming from the Philippines, a lot of people would normally, when you're applying abroad, you would think, oh, what university is quite famous, they would say, famous. That's one of the criteria. Actually, I'm mentoring a lot of graduate students, and I was telling them that do not do the criterion that I did in the past, because it was challenging and, to be honest, not as fruitful as I wanted it to be. Because before I would normally think, okay, what is the best institution to actually give me an education on this particular expertise? But it's not only the institution. What is most important is actually the mentor. So I was advising a lot of graduate students right now to look for laboratory and mentors that could best bring the best out of them, not just institutions. Because in the Philippines, we look at institutions like Ivy schools and Russell schools, like, you know, they look at it because of the accolades of it and think that, oh yes, I wanted to do chemistry, and what best school could offer chemistry, and they look at QS ranking, and that's all they think about. But in reality, when you do graduate school, you have to think about the mentorship, and this is why I'm also opening in this talk that we have to be as you know, early research scientists. I wanted to have gotten those wisdom of actually looking into mentors more clearly, because I've done a lot of degree and I've moved from one university to the other. And to be honest, the professor who made a huge difference to me are the professors who are humble, and yet who would actually dedicate time to mentor you, to build you, not just as a scientist, but to build you as a person. And so I could only, and it just so happened that when I was in Cambridge, one of the greatest persons that I've met who actually mentored me was not even my technical thesis advisor. Professor Kyoto, who happens to be a Nobel Prize winner in physics, but one of the most humble professors that I've met. And I grew more from him more than from my technical advisors in Cambridge. And at Harvard, I was lucky that my mentor is an amazing mentor. And so I grew more from him than anybody else, although I have several mentors at Harvard. But I realized that a lot of my energy and a lot of my growth come from the very person who actually motivates you to do great science that impacts the people around you, science that actually make a huge difference to the community. It's not just about applying for grants that would get you more money or get you more publication, but it's actually about doing science that could benefit a lot of people. And so this next talk is about the challenges, that what I call valley of death of translational research. And this is the stage where I'm at the moment. So I did a lot of basic research when I did my master's and PhD. And so we're moving to translational research. So that's what I did 2 years ago, developing new devices, diagnostic devices, and even intervention devices. And how do we move forward from that science to actual clinical practice, to bedside, wherein we actually impact a lot of people? And there is this value of that for translational science. And this is because, you know, a lot of this would be because of funding majority and how to follow through. And a lot of scientists are not really equipped to do technopreneurship. And so I'm really privileged to have gotten into technology transfer and technopreneurship subject when I was in Cambridge to Judge Business School, to move forward to actually producing something that could benefit the society. And this value of it is what I am trying to overcome together with other Filipino scientists whom I've started or who co-founded the biomedical startup that we did just a couple of months ago. So I wanted to move from a basic research to actually something that is clinically relevant. And you can do this either by making sure that your research would gain enough momentum to get funding for it to have like a clinical approval. Or you could also start building. A lot of people from Harvard, MIT started doing startups. And I wanted to bring this kind of mindset to the Philippines as well, especially during the pandemic. And this is why we were trying to overcome the value of that by actually creating a biomedical startup in the Philippines with an idea that the science, the education, the trainings that we get abroad could actually be beneficial to the Filipinos. And the last slide is just to show you that from stepping on that Nobel Prize huge medal in Stockholm 15 years ago, one of my professors handed me the his Nobel Prize medal. That's Professor Kyoto, because I asked him after the lecture, like, Professor Kyoto, how does it feel to have a Nobel Prize? And he told me that it makes no difference. And then he handed me the medal and he told me, you can tell me yourself. And I touched the medal and he asked me, did it make a difference? Did you actually make a difference? And that's the reason why my talk is more about the journey of becoming a clinical scientist. So it really didn't make a difference. At the end of the day, it's the people that have gained impact, that have benefited from our education and trainings that motivates me the most. So at the end of the day, yes, my inspiration about going to Nobel lectures. I've been to Nobel lectures so many times. Like when I was in Cambridge, the university, my fellowship was actually paying for me to attend these conferences every single year. And a lot of the works, yes, it made so huge difference. But one thing really inspired me the most, that's Yu Tu, the Chinese Nobel Prize winner in physiology who actually saved millions of people. And until now, it gave me a goosebumps, and it made me ponder more upon what Professor Kyoto told me. That whole thing, a gold medal, does it make a difference? And he was, staring at me like, did it feel different? Did it make a huge difference? And he was telling me essentially that what would make a huge difference out of my PhD in these universities is not the publications that I'm getting. Yes, that's one of it. It's not the promotion of having additional letters after my surname, but rather, did it make a difference to the very community I'm living? And at the end of the day, after all the degree that I took, and the work that I did, what really is motivating for me and fulfilling is to see that this science, this education, this training at the end of the day could better at least the lives of the people around me. So I hope that graduate students would and from the Philippines and from other developing countries would also, think it through, like what degree they wanted to do. It's not the accolade, it's not being in Ivy schools or privileged institutions that really matter. And I've realized this wisdom from the very people who actually are holding this Nobel Prize medal. And the question was, did it make a difference? Yep, so that's the end of my talk. I hope this, this helps a little for the future graduate students there in the Philippines and the high school students too.
Thank you very much, Jal. Indeed, your talk, Beyond Science is Empathy. I remember one time when I was asked when I was doing a postdoc to rank data, people, and something else. And you have to rank it. And then it made me think, which is more important? Is it your data or the people around you? Thank you very much for that very inspiring message, Jal. At a very young age, I hope you inspired these young, driven and ambitious kids here. That it's not about accolade, but it's about what you want. You need to give back to the people. Anyways, let me call on, maybe you should stop sharing, Jal. Let me call on Cheryl and Amy now for the Q&A.
Yes, we do have a couple of questions in the panel. Some of them were answered, and so we invite people to check them out. And is there somebody who's who would like to raise a hand and ask our speakers? Well, our speakers are still here.
Yes, they're here.
There was one who raised a hand a while ago. Oh yeah, I think it was Sherry. And so we can allow them to talk. Okay, while we're waiting for a few more questions, I think one of the lessons that we have here is, to actually have a village and seek out mentorship. And so for our panelists, how have you yourself sought out mentorship? I think about this too, and it's like, how do I do it? How do I do this? How would you really initiate it? Is there such a thing? Did you go through a certain process of acquiring a mentor for yourself? And so if you have, please do share. Perhaps I would start with you, Jal, because you have mentioned, you were able to find somebody who's not even your technical advisor, right? So I'm just curious, how did it, come into play?
So mentorship is critical in yes, I wouldn't be where I am without ample mentorship from people. And it's true that I wouldn't be here, like what Professor Tigner was saying, that it takes like it takes a village. I'm not sure if that's the right, Professor. I apologize. So anyway, so the mentorship in it's different from different universities, but what I could generalize is that great mentors and great people actually seek to improve you as a person more than just to improve you as a scientist. So that's what I learned when I met when I started my journey into science. I have a primary school teacher who inspired me to do maths and science. A primary school teacher who became like my mother. And when I moved to high school, it's the same way. I met a professor who inspired me to do chemical engineering and to be a better person, to actually use my skills in science and engineering to become a better person. And it's the same way in UPLB. Professor EJ was mentoring me not just to become a great scientist, but also to become a good person. And when I was in Cambridge, although one of my advisors is really brilliant, it was Professor Kyoto, who's very humble, that actually inspired me more. And being a Nobel laureate, and yet, asking questions about life and asking me what could I do to better the society that I'm in is also what inspires me. And now at Harvard, Professor Sally is the same way, a clinician scientist who wanted to make a huge difference to help community. So I would say for graduate students that, on a more practical side, if you're looking into universities and specific laboratories, email the postdocs in the lab and ask how they are doing. How is their relationship with their principal investigator or mentors? Because it will give you an idea of how they will treat you eventually. Because we don't have an app that shows you the integrity, respectability, credibility, kindness of a certain person. You really
the
have
way they
to
teach, they do, right? With the way
Exactly.
but not the personality itself.
Exactly. We don't have that training to how I wish we have a university that basically teaches how to become human, how to increase our humanity rather than increase one particular skill, but to actually help us become a better person. And that way we could just check the grades of the professor in this school of life if they have an A for kindness, and then we can pick that professor, but it's not like that in real life. So my advice is to email the PhD students or the postdocs and hoping that they would respond about the relationship with the current professor or principal investigator of that lab before you apply to that lab.
Well, thank you very much for that suggestion and for that answer. Anybody else from the panel who would like to chime in on that? There was a comment. There was a comment here that somebody found their PhD mentor by watching Paas's seminars. Look at that. It's amazing.
So what I'd like to add with that, because I was in a situation where I really cannot apply to anybody who I wanted to, because I had very limited choices by the fact that my husband was already a professor at Bowling Green State University, so I could not possibly drag him to wherever I wanted to go because he had a job. And also, we had a family, so I could not have him living in my one city and me in another city. So I was limited to applying in Michigan. And actually it turned out to be very lucky. I mean, Dennis was a wonderful mentor in that he knew what it takes for us to succeed in academia, but he also pushed us so hard sometimes that we're like, oh no, I don't want to do this anymore. I'm ready to jump off the train. And then my husband looked at me and he says, you know what? Sometimes when people push you to your limit, you don't realize what you're capable of until you reach there and know that you can actually do it. And so when I was in his lab, I had 2 kids to raise. My kids were in all kinds of activities. My husband was driving 70 miles a day. And I just made it happen. And I took the good that I have. And it was a lot of pressure because also every postdoc in the lab had a grant. And so within the first months, I was totally freaking out. Like, I don't want to be the only postdoc here who didn't get a grant. And so he pushed us to a lot of limits that we realized that, hey, I can actually do this. And then looking back, I came out with 7 papers out of the lab, an NRSA grant, and that was my ticket to an academic position. And so, so it was a very good mentoring. All of us were very successful coming out of the lab. And so I sort of fell into a situation where I was mentored very well, was under pressure, but that's what academic life is, particularly in the US. The first 5 years before you get your tenure, you almost don't eat or breathe until you get that paper and you get that grant. And that's what life's all about. And that was a really good training ground for that. And then when I got into Frank Berger's lab, who was my mentor when I came, he was the research faculty, he hired me as the research faculty. He was also, very pushy, but a little bit nicer than Dennis. But the one thing about all my 3 mentors, including my husband, was they gave me the ability to think independently and try out my own ideas. I remember coming up from a lab meeting and Dennis specifically telling me, do not do that experiment. That's going to be a disaster. And I'm like, went back straight to the lab and did the exact experiment and came back and said, look, it worked, and it became a standard protocol in the lab. So there's always a fight for independence versus listening. And now when we have new faculty, they always emphasize mentoring. But I always tell them too, it's not going to be your mentor's fault that you're not going to get tenure. In the end, you judge your own research, you know your own field better than any of these mentors. And sometimes you got to stand up to your mentors or follow them. It's always that give and take all the way through. That's been my experience.
So may I chime in?
Yes, Senia, please.
Yeah.
Yes, please.
Okay. So I think mentoring is really key, as my previous speakers have said, so Marge and Jalik. And I think my first mentor was actually my mother, because one, she pushes you to the limit. Yes. She has very high standards. So, you have to rise up to the occasion, so to speak. But also when I was doing my doctorate, I was in Germany. I had no family at all except my husband. I had 1 kid and another one on the way. And so for the first child, I have to do this 8-hour hemodilution experiment with a rat. And there was no yaya, okay? So what do I do with a kid? I put the playpen beside my operating table. So the kid is there while I'm doing the experiment. It's an 8-hour thing. There's nobody else that you can count on except yourself. So first you have to believe in yourself. And luckily, my German mentor, despite all of the stereotypes that are generated by the American media, he was very understanding. And he, if I needed to go home, if the kid got sick, had to be brought to the hospital, that's not a big deal. And that's not always the case. You have to have a mentor who actually believes in you, nurtures you, understands he was very human. In other words, who respects you, and that's really key. And whether you're a pre-doc or a postdoc or even early in your career, you always have to have a mentor or an ally. So the mentor need not be an official mentor with whom you do your thesis with. Actually, you can have a mentor who is a life coach, not necessarily knows your science, but can lead you along the way. And I think Giselle is here. She will attest that I have been a mentor to many of my students in the College of Medicine. They still interact with me all this time. And when I moved to the United States, I mentored all the postdocs under me in the lab. When I moved to NIH, I mentored all the applicants in the grants to tell them how to do better science, how to make their grants get funded, etc. And then eventually, when I became very senior as a program officer, I would mentor the new incoming people to how to do their jobs correctly. So mentoring never ends. I think there's always an opportunity to mentor the next generation. And there's always an opportunity to be mentored yourself. So I'm a perpetual learner. I never stop learning from others. And they're not necessarily older than me. They can be younger than me. So I have lots of good younger people in my current position who teach me things that I don't know. I think so. It's sort of a give and take thing. They know better than you in IT, for instance, and I'm stupid. And they tell me how to do things correctly, for instance, and they can learn from you too. So I think really we talk of science as if it were in a silo, but it's actually not. And the human aspect is just as important, if not more important than others. And I apologize that my talk was absolutely not inspirational. I did not know that that was the goal for this breakfast meeting. I thought it was, an explanation of diversity, etc., without knowing that should be a to jumpstart other people's careers, in other words.
But we learn a lot, Senia. So thank you for that. In my case, choosing a mentor, again, there's no way. It's like just looking at their research interests. That's where I look at, whether they are colored or not colored. I just look at whether we have the same research interest. And I was lucky, maybe prayers, because again, going to another country and not knowing anyone. So, and then working for 4 or 5 years with a person or with his team, research team, that could be a very big challenge for a lady, a woman scientist, wherein it's male dominated in other Western countries. So I was lucky that he was also married. He was married to an Asian lady, but a Briton already. And so she would be able to understand the culture of the Asian. So he would ask me, things that I did not expect to be asked by someone who is my mentor. So it could also break or make a graduate student. You have to choose the correct mentor. Again, you also have the right to change mentors, your supervisors. If you don't see eye to eye, then you don't need to be the sacrificial lamb to waste your time not being able to communicate with the mentors. Sabi nga, if the mentor would be too technical, leaving out the heart or the humanity, then you have all the right to choose your own mentors. Yeah. So I wish everyone in our room, in our virtual room, the young scientists, specifically the female young scientists, the best of luck. Thank you, Gladys.
Thank you very much for those very inspiring words. Ms. Cheryl, would you like to call on some of the few raised hands that we have? I think Rosa.
And Giselle is also raising her hand.
It's all right.
Yes.
Let the others speak first. Thanks. It's all right. Thank you. Just wanted to congratulate everyone.
You can call on me. Oh, nawala. Mario Santo Domingo. Yes. Yes, sir.
Yes, hello.
Hi, Mario.
Yes, congratulations to everyone. Is my video on or?
No.
No.
I think I cannot show myself. Okay, but anyway, congratulations everyone for telling us your awesome.
Sir Mario?
Maybe
Muted now.
Mario, you're muted.
Hello again. Sorry.
There
you go. I upgraded him to panelist. That's why you can see him now.
Yes, congratulations, everyone. I'm really drawn to this topic because I'm a community and applied social psychologist. And I believe that all empowerment programs should have a diversity and a developmental component. And so talked about your journey in science. I have a very memorable, observation about my own daughter's journey in science. She's now a junior computer engineering major at the University of Maryland. And when she was in middle school, I observed that when she was in a team with boys and some girls, when they're given a particular problem during a competition, the boys almost always, are the ones who try to be at the table, try to solve the problem. There was a time when the boys couldn't solve the problem, and then these two girls, including my daughter, were able to solve the problem for the and that was about parallel and scenario is probably multiply, repeated over many classrooms, many laboratories. And I was advised to be an equal chance, for girls, for example, who are less aggressive, less but equally brilliant, or even more classmates, who are boys. How would you perhaps provide solutions to this particular? Anyone can offer a response.
I think, Sir Mario, you were asking for how to promote more active participation for women, like how to get them.
Not even, to give parity, because I noticed that in some schools they form all girls teams, and I asked a coach, why are you doing that? Well, it's because of the situation I mentioned, to give them space to be be able to participate without the issue of having to compete, with other gender, something like that. But this is really something that has kept me thinking, about gender and science. And in fact, I had another observation. I looked at the number of 12 women and 29 men. I don't know if this is something that is concerning, or this maybe you can say, well, it's gender blind, the way we do this. But then if awards are reflection of excellence, and the productivity, is it about right that there are only 29% women scientists who have achieved that particular level? And it's even worse in the arts. It's only 15% are women, and 85% are men. So maybe the scientist women are doing better than the artist women, if we look at it that way. So just some observations that probably I thought that I'll relate here, and maybe you have any comments, I'll appreciate it. Thank you.
Mario, I could not really get most of your question because my internet is so unstable sometimes, the sound quality was not good. But I would just like to answer one thing about the grant awards from NIH. And I said that most of the time, if you have 100 NIH awards, 70 go to men and 30 go to women. It's not because the success rates of women are worse. Actually, the success rates of women have improved and even surpassed those of men. In other words, if there were 30 women who applied for the grant, you would expect that they would get less grants because there are only 30 of them versus 70 men who applied. So it's not really the success rate, how many grants of your applications, if you're a woman versus a man, which matters. But how is it that not that many women apply compared to men? So why are there less opportunities for women to apply? Or why don't they apply again if their grant is not funded? I think this is more of a social determinant rather than a question of ability, because women actually succeed better. They can succeed better on their second application for an award. But like, if they get a bad score, oh, they get discouraged, they will not apply again. So there are a lot of issues which are not entirely because they are less capable. You know, first, the science identity is not there. They think that they're not as good as the men, and so therefore, jahi naman, if I keep on applying, get rejected, you know, something like that. And then to your example of having all women teams so that they don't have to compete with men, maybe that's good in a way, as you said, to have them in their own space. But in a different light, that's also stigmatizing, you know, just like we say, okay, these are applications only for diverse people. Then when you get it, they say, oh, he only got it because he was diverse. So you're always considered second class. You know, I think what is better is that you feel capable enough, you have self-efficacy to compete with fellow men and know that they're no better than you. And maybe you're even better because you can multitask and they can't. You know, you can cook your breakfast and send your husband off and care for the kid and still write a grant. I don't think men do that, you know. So during this pandemic, they stayed home, yeah, but they didn't take care of the kids. They were still writing their grants, whereas their wives said to do everything else. So that is how it is, you know.
Yeah, I think Ma'am Senia, what you mentioned there is like the sort of tokenism, right? The term, right? Well, thank you very much for that. Ma'am Giselle, you were raising your hand a while ago. So
yeah, no, I just I'm overwhelmed by what I heard today, and I'm so glad that our 4 women scientists spoke to this group of young women who are the future leaders of science here and worldwide. And I just like to echo everything that Senia said. So my questions were related to what she just said, and she just talked about it. And she talked about interacting with young people in the research group, mentoring them, but learning a lot from them as well. And then she talked about multitasking. That's a unique quality of women. It's an advantage. And third, I just wanted to tell everybody that Senia made a great impact, not just as a researcher and teacher, but as an administrator in the physiology department of the Iupac College of Medicine. And that way, she's able to get many more faculty mentors and guest lecturers to share their knowledge with the students. And so I think that highlights what it is that women can do. What are the unique qualities of a woman scientist or a person that would compensate for all the challenges, additional challenges that women face being female, and then generally being less aggressive, and then of course being the mothers in the family who would have to bear the children and to nurture them through early and later childhood. So I always say that women leaders are unique, and it shows the way that Tina described her journey, and of course Marge, amazing, and our new leader is Jalil, who is simply so inspiring. So I'd like to ask you how you would mentor your mentees now, the next generation. And I always say the next generation should exceed us. Okay, so that's the selflessness of a mother. You're an academic mother. So I always talk about academic families, creating the academic families. Your academic lineage actually is now Jalil from Professor Kyoto. You are descended from him. So now how are you going to mentor the next generation of scientists. Thank you.
It's actually a very scary task, Mom Giselle, to mentor students. Yeah, and to me, for me, my goal is to basically give them everything that I know, train them in the best way that I could. So right now, I'm actually mentoring more than 15 students from UP-LB alone, and then a couple more from UP Diliman and high school students. And most of the time, I would spend like really quality time with them, asking them 5 minutes, asking them how they're doing, how their family are doing, before we actually start talking about science. Because one thing that I observe is that if you're talking with a person who's happy, that students actually absorb more of the discussions than when you're talking with someone who have initial problems or conflicts at home. So I always wanted to establish like a friendship. I wouldn't say mother to daughters or to sons yet, because I have no experience at being a mom, but I have plenty of experience being an aunt and being a sister, an older sister. And for me, it really makes a huge difference to establish that interpersonal connection, like being friends with them, so that they could open to me what other personal struggles they have. Because this is also what I learned from my academic parents. I call them my academic parents, my academic dads and academic moms, that throughout my journey, they weren't only mentoring me about science, they were actually mentoring me about life. And it makes a huge impact to where I am, to who I am right now. So beyond this scientific career, the very person who I am right now is actually molded by these academic parents. And that's because they treated me like their own daughter in a way. And so I wanted to channel that the best way I could. And of course, to still like what the moms in the speakers said, like to push them to their limit, like an actual mom, like to always inspire them, but also push them to achieve what they have, what they could do, and to, like I always tell them, surpass whatever it is that you're getting from me. For me, becoming successful would tantamount to you being a lot better than who I am as a scientist and as a person. So if you come out of this mentorship a lot better than me, that to me is my ultimate achievement.
Thank you very much for that. So I think, Ma'am Gladys, we have last one question, and I saw one from the chat, which I would address to everyone for our panelists, and that is, how do we really empower women in pursuing a STEM career? I think that's from Karen. So that will be our last question. So anybody?
Think of, first of all, you have to believe in yourself.
Yes.
And know that you can do it. There is always something in the way that will prevent you, but if you have the passion for what you're doing, you'll get there. And again, mentorship is key, but you need also allies. You know, so it doesn't mean that you have to be mentored only by women, or that you have only women allies who sponsor you through your careers. A lot of men who hold power can also help you get there where you want. So I think those are important. But first of all, you have to believe that you can do it.
For me, I think that you need to have the passion for science, and sometimes that gets instilled in us, even as kids. You know, I learned to love math and science through my teachers in elementary school, and kept an open mind for that. And I've always been inclined to favor all my science and math courses over everything. And yet I didn't really know how to channel that because all of my role models were either wanting to be a teacher, a professor, or a teacher, or a doctor, or a lawyer. There weren't really many others that were doing basic sciences, but things like the article I read really sparked my imagination. So I think to have a fertile mind, to be open for everything, and then just I guess I was a dreamer. I would just dream of doing these things, even though I had no idea how to get them done. But I could see from, read a lot. I could see from everything that I read that there were all these potential careers out there. And somehow I found a way to make it happen. And so just by really studying all of the science and being engaged in it kind of opened a lot of doors. And so as teachers, our part then is, if we see this in our students, is also to encourage them to pursue these careers, to pursue their interests, because in the end, the thing that carried me throughout this was really just the love for doing science. I tried a career in accounting because I thought that's what I should be doing because I had family, but it just didn't work. I was just frustrated. I thought I was just going to go die and not do anything. It was exciting. I was adding things, but I was just adding the same things day in and day out. And now with a career in science, I pretty much do something different almost every day. I teach with passion with the things I do. And so if our students can see that and we can convey that to them, I think that would also encourage them to pursue a career. And like Xenia said, you really have to believe in yourself because in a PhD, 9 out of 10 experiments will fail. And if you don't believe in it, you're just going to give up. And so, I think the passion should be there. The fulfillment when you achieve something good, even if it doesn't happen all the time. And if we are good role models to the girls around us, then I think we already serve as the inspiration for them to pursue that, and we can help them to nurture that interest.
Maybe another one is to persevere and hard work. So there'll be lots of pitfalls and valleys. Just embrace all of this and move on with your putting your head above water.
Yeah. And having kids really adds more challenges. I can still remember doing Western blots, and I will take them home and put them on my daughter's toy phonographs, toy record player, so it will swish around and get mixed and then change the buffer. And then my kids will be looking at it and say, "Mom, what's our experiment today?" So I'm doing my Western blots in the kitchen and then taking them back to the lab the next day. So it was a lot of things that we had to put up with. And, I would wake up at 4 a.m. so I could start my experiment and get done at 2 a.m. the next day. In between that, I'm taking care of my kids, bringing them to daycare. So there's a lot of challenges if you're a woman, and it's easy to give up. But I think if you believe in yourself and if you really love what you're doing, all of that, the people always ask me, how did you do it? I'm like, I don't know. I never think that I was doing something that was imposed on me. I just doing something that I liked and found a way to make it happen. Because, I have students who don't have kids who find a hard time coming to the lab. And then I'm like, don't talk to me about that. I had a 2-year-old and a 2-month-old when I was doing what you're doing. And so they just start like, okay, fine, I'm not going to complain.
Yes, thank you very much. Okay, so I wrote down like a list here that just to summarize what all of the speakers have shared. So these are the lessons: believe in yourself, master one science, have the passion for what you do, find your partners who are your champions, your husband or your best friend. Look for a good mentor. It doesn't have to be one person. It can be a combination of 3 or 5 people. Okay. And then emulate their best qualities. I think that's the best. It's very difficult to really look for a good mentor. But the good thing is you realize that it's difficult. So you try to be a good mentor to your students. I think that's the best way to do it, so that they can find a good mentor. And what else? Maintain a village. Thank you, Marge. You had a good village. That's why you
You
were
have a very good village around me.
you had a very you were very successful. And I think be humble, right? It's very important. Ask for help. Don't be afraid to ask for help and just admit that you don't know everything. I think that's very important.
Especially if you don't know it. Yeah. Ask for help.
Even up to now, don't that's what I learned. It's easy for me to say that to admit that there are better students, more intelligent people than you, and then you just tell it to them, and some of them, because it's in the Philippines, they're still surprised to hear that from you na. Hey, you're better than me. But admitting that they can be better than you is actually, I think, very important. And what else? Amy, can you continue the list? I think the fourth one.
I think the fourth one is the embrace the valleys and frustrations from Dr. Binac, because, you know, it's important. It's part of it. It's part of the journey. You know, there's always going to be that. But as long as you have those 3 points before, then you're all set in, you know, meeting your challenges and frustrations. And I think part of maintaining that village too is really asking for help. Like, for me to be here, I have to ask my friends, like, can you and your son go over so I can
so be part of the village.
Yes, and we call each other
and your son to the camera.
Yeah, and then just to remind everybody, we posted the link for the survey. You have to answer the survey forms first before you can get the certificate. Certificates will be provided. You know that it's very important here in the Philippines. Senia and Marge, it's all about certificates here. So, so we have the certificate. I keep telling everybody about that. So we will be sending out certificates. Just please answer the survey form.
Yeah.
Okay. So I think this is it. And then speaking about certificate, let me just share. I hope I can share now the certificates that we prepared for the speakers. And then after that, I will call on our Dean Cece for the closing remarks. Let me just share. And I hope this time, okay, I can really share the, oh my gosh, can you see the, no, what can you see right now?
Survey form.
A survey form. Okay, good. Okay, so let me just, sorry, here. Can you see this? The certificate?
Yes.
Oh, yes.
Okay, let me just read it real quickly. Just one, and I'll be just enumerating the names. So IUPAC Global Women's Breakfast 2022 and the Philippine American Academy of Science and Engineering in partnership with the Institute of Chemistry of the University of the Philippines, Los Baños, Integrated Chemists of the Philippines and Advancing Chemistry for Tomorrow, award the Certificate of Appreciation to Senia Tigner, to Maria Margaret Pena, Christina Binac, Jal Jane Fojas, for having shared their knowledge and expertise as speakers during the IUPAC Global Women's Breakfast 2022, held with the theme Empowering Diversity in Science on February 16, 2022 via Zoom. Signed by Mariano Santo Domingo, President of PAASE, Gladys Complete, yours truly, Organizer and Vice President of PAASE, Marivic Laksamana, Director of the Institute of Chemistry, UPLB, and Lilibeth Ko, Member of the National Board of Directors, Integrated Chemists of the Philippines. I just want to share that. And of course, the participants will be able to receive their certificates after answering the survey. So now, I'd like to call on Dean Maribel Cece to give the closing remarks.
Good morning. Can you hear me? I hope you can.
Morning.
Yeah.
Yes.
I thank Dr. Gladys Charis C. Completo, Professor of the Institute of Chemistry of the College of Arts and Sciences of the University of the Philippines, Los Baños, and currently the Vice President of the Philippine American Academy of Science and Engineering, for inviting me to be a part of the Iupac Global Women's Breakfast 2022 with the theme Empowering Diversity in Science. I understand that this is held as part of the Philippine American Academy of Science and Engineering, or PAASE, Chemistry and Biochemistry Research Expertise Cluster Webinar, and is co-sponsored by the UPLB College of Arts and Sciences, Institute of Chemistry, Integrated Chemists of the Philippines, and Advancing Chemistry for Tomorrow. I trust that you found all our participants, the messages and the insights presented by today's speakers truly enlightening and inspiring. Empowering diversity in science is both disturbing and challenging. It is disconcerting to realize the persisting pervasiveness of gender inequity in science and technology career paths. It is a formidable challenge to individuals and institutions to make the S&T playing field focused on competence and blind to gender differences. To my mind, a large part of the challenge to us, women in science, is breaking the so-called crystal ceiling in the leadership of our national institutions of science, the equitable diversification of opportunities to serve the interests of science and society at the highest levels of our bureaucracy. This is not to say that the men who have helmed and continue to helm our science agencies are not up to the job. It is just that there are women who are equally capable of doing the job, but for one reason or another, do not get the opportunity to serve. To illustrate, our Department of Science and Technology, the cabinet-level institution mandated to provide central direction, leadership, and coordination of scientific and technological efforts, has been almost consistently helmed by men since the establishment of its precursor, the National Science and Development Board in 1958, to its transformation to National Science and Technology Authority in 1982, and up to the present Department of Science and Technology, or DOST, that was created in 1987. In its 64 years of evolution, DOST has been led only once by a woman of science, in the person of former DOST Secretary Estrella F. Alabastro. Its sectoral planning councils, the Philippine Council for Agriculture, Aquatic, and Natural Resources Research and Development, the Philippine Council for Health Research and Development, and the Philippine Council for Industry, Engineering, Industry, Energy, and Emerging Technology Research and Development are all currently headed by men. Our National Academy of Science and Technology, which was established in 1976 to, among others, advise the President and the Cabinet on matters related to science and technology, has had only 2 women of science presidents in its more than 45 years of existence, Dr. Perla Santos Ocampo and its current president, Dr. Rodora Azanza. Of the 42 individuals that have been conferred the Order of National Scientists since 1978, only 11 are women and only 4 are still alive. Dr. Claire R. Baltasar for Systematic Entomology, Dr. Mercedes B. Concepcion for Demography, Dr. Lourdes J. Cruz for Biochemistry, and Dr. Dolores A. Ramirez for biochemical genetics. Of the 114 academicians that comprise the NAST, only 22 are women. 6 have passed away. The NAST can annually recommend 10 scientists to the president, to whom he may confer the rank of national scientist. Membership as academician in NAST is upon nomination of 3 members and the majority vote of all living members of the academy. Its total membership, initially pegged at 50 academicians, may be increased by a 2/3 votes of its member and upon approval of the president. Our Department of Health, which next to the OST is probably the most S&T significant cabinet level office, has had only 3 women of science at its helm since its inception in 1941 as part of the Department of Public Instruction, Health, and Public Welfare. Dr. Carmencita Riodica, the first woman DOH secretary, appointed by former President Fidel V. Ramos, who served for just a little more than 2 years, from April 8, 1996 to June 29, 1998. Dr. Esperanza Cabral, who was appointed by former President Gloria M. Macabacal Arroyo, and who served for less than a year, from September 1, 2009 to June 2010. And Dr. Janet Garin, who was appointed by former President Benigno C. Aquino III and served from February 17, 2015 to June 30, 2016, for a little more than a year. There has been 4, if we include Dr. Pauline Ubial, who was appointed by President Rodrigo R. Duterte and served from June 30, 2016 to October 10, 2017, but failed to get the confirmation of the Commission on Appointment. The Department of Agriculture, which is also an S&T intensive cabinet level office, has never had a woman secretary, much more a woman scientist. There can be a long list on this. As we celebrate the accomplishments of women in science, let us call for more relevant reforms in our educational institutions that will encourage and competently capacitate more girls and women in lifetime S&T careers through progressive nurturing of science-based values, knowledge, and skills. Let us call for more affirmative actions in research laboratories and other S&T workplaces that will remove any whiff of gender-based discrimination. Let us call out our national leaders to equitably open opportunities for women in science to take top leadership roles in both public and private sectors towards a science-based economy and society. Thank you and good day. May God bless us all, always.
Thank you, Dean Cese. So it's already 12 noon. It was really a very fruitful webinar. So thank you very much for all the participants. We had at one point more than 265 participants, and it's now going down to, it just went down to 239. Thank you for staying for 3 hours to listen to all the speakers. So maybe we should have a picture so that we have yeah, okay. For all the panelists, please, all the panelists, join us. Okay. And we can have a picture. Help me, guys, because my, what do you call it? My panel can only accommodate, I think, 12. Okay. All right, hold on. Smile. Then smile. Okay. Wait lang ha. One more. I'm not good at this. Okay. Thank you again. Thank you very much. See you next year, February 14, another Global Women's Breakfast. And good morning, good night. You should sleep now, Senia.
Marge and
Marge
Senia.
and
Thank you.
Gladys.
Oh,
Thank
thank
you.
you.
Thank you, everyone.
Thank
Thank
you.
you.
God
Thanks for the
bless.
invitation.
Thank
Yeah, and thanks
you.
for all
Very
your
much.
talks.
Thank
Gladys.
you to all the attendees.
Thank you,
Bye.
Cheryl. Thank you, Aimee.
Bye.
Bye. Thank you.
Bye.
Princess.
Thank you.
Bye. Thank you.
Bye.
I'll end it now.